Determine the area of the largest rectangle that can be inscribed inside of semicircle with the radius of 8 units. Okay, let's see what we have here. Radius 8 units. Here we have radius. Okay, this is 8 units, which means here also 8 units, right? That's our radius. Okay, so, and we need to determine the area of the largest rectangle. So let's start working. If this is our x, right? This is our y. So this is going to be our x, and this side, vertical side, it's going to be our y. So for rectangle, the area it's going to be, let me write down. So one side of rectangle is going to be x plus x, right? Because this is also x. So it's going to be x plus x. I'm writing down like this so you can see. And times y, the height or the width, whatever you want to name it. Okay, so which is going to be equal to x times y. So at this point, all we need to know x and y. So how we can find our x and y? We know that the angles of rectangle are 90 degrees, right angles, which means this one is also right angle, correct? And if in the right angle, we can use Pythagorean theorem. Pythagorean theorem says the legs of the right angle, which is x and y, if we take square of these legs and add them up, we will get the square of the hypotenuse, which is our 8. Hypotenuse is the side that is laying against the right angle. So, which means we get x squared plus y squared is equal 64. Okay, so from here, how much will be my x? X is gonna be square root 64 minus y squared. Let's not to forget that we are going to have plus minus here, right? Because we are taking square root, positive can come out and negative can come out. So because the negative, it's not going to work for our case, therefore we are going to have only the positive portion of it. And if we use the area, knowing x, so it's going to be twice, well, let me write down 2y, here it is, right, 2xy, 2y, and square root 64 minus y squared. Okay, then using the algorithm for maximum and minimum, which means we have to get derivative and assign it to 0 to find out which area is going to be the largest one. Therefore, we are going to take now derivative. So dA by dy is going to be equal twice square root 64 minus y squared. Let me write down the principle how I am taking derivative. Since I have here multiplication, it's going to be derivative of product, the derivative of multiplication. So u v prime is equal u prime v plus v prime u. Yes? So derivative of 2y, let me go here slow. 2y prime times 64 minus y squared, and then plus derivative of, 64 minus y squared times 2y. Okay, so let's see. This is going to be equal to square root 64 minus y squared and plus 2y times derivative of 64 minus y squared. So this, if I represent, let me see, square root of 64 minus y squared, it's going to be equal 64 minus y squared to power 1/2, right? So if we take the chain rule, it's gonna be equal times 1/2 comes in front, and 64 minus y squared to power negative 1/2, and times negative 2y. Why negative 2y? Because we are getting inside and taking derivative of inside of square root, okay? So this is what we get. So here we have a condition for this case and for this case that y squared has to be greater than equals 0, right? Because it's under square root. So I'm going to write down that y is going to be greater or equal than 0 and less equal 64. Okay? Because y underneath of square root, it's going to be maximum 0 or 8. All right? Okay, so we already have derivative. Now let's do simplification. dA by dy is equal twice square root 64 minus y squared plus 2y times 1/2 64 minus y squared and times negative 2y. Well, let's we already have all this, right? Yeah, I just rewrote it in a readable format. Okay, so now we need to assign the a by the y equals 0 because we want to find the maximum, right? Maximum rectangle, the area of maximum rectangle. Okay, well, let's do it. 2 square root 64 minus y squared minus 2y squared square root 64 minus y squared, and all this is equal 0. All right, so to solve it, what is gonna happen? So if I bring to common denominator, right? Common denominator is going to be what? 64 minus y squared under square root. And whatever we do divide by, we need to also multiply to keep the balance. 64 minus y squared square root. Okay, so now we can drop this denominator as we know. Okay, and get the result, which is going to be twice 64 minus y squared minus 2y squared is equal 0, right? So from here, it's going to be twice 64 minus y squared is equal to y squared. And then this 2 and 2 is gone, right? What is it going to be now? 64 minus y squared equal y squared. And from here, 64 is equal to y squared. 64, y squared is equal 64 over 2, which is going to be equal 32. Okay? And from here, y is going to be equal plus minus square root of 32, which is going to be, let me see, 32 is 16 times 2, so it's going to be plus minus 4 square root 4 square root 2. Okay, this is we calculated how much y is. Okay, now we need to figure out our x since we have our y, and we are going to go via following formula. Here it is. X is equal plus minus square root 64 minus y squared. That's what you, as you remember, we drop all negative portion of square root because we are doing measurement and we don't measure in negative. So x is equal square root 64 minus y squared, which is going to be square root 64 minus 4 square root 2 squared. And that is going to be 64 minus, so 4 times 4 squared is 16 and times 2, 32. Okay, which is going to be how much we are getting? 32 square root of 32, which is going to be again 4 square root of 2. So we have x is equal 4 square root 2. We have y is equal 4 square 2. So we can find the area, right, of rectangle. Area of rectangle is equal 2x times y, right? Because let's go back to our picture here. So we have 2x, 1 and 1, 2x, and this is the height, y. So we need to multiply length times width to get the area for the rectangle. Okay, so we multiply 2x times y, and we are going to get a is equal twice times 4 square root 2 times 4 square root 2. And what's going to happen? 2 times 4 times 4, it's going to be 32, and 32 times the square of square root 2 is only 2. It's going to be 64 units square. So this is practically going to be our answer. And let's see, we here put condition, where is it? Oh, here it is. We put here condition that y can be greater than 0, less than 8, which prove that our answer is fitting within condition limit, right? 4 square root 2 is less than 8. So Therefore, we have the maximum area, the area of the largest rectangle that can be inscribed inside semicircle is 64 units squared. Okie dokie. Thank you for watching. See you next time.